I'll discuss today the high frequency response on the common emitter two-stage. Now we know that in a simple common emitter amplifier, has a gain. Voltage gain equals to minus Gm into RL. But due to the presence of the emitter resistor, as we are looking here, common emitter two-stage amplifier, due to the emitter resistor, the voltage gain reduces. Why reduces? Because of the emitter resistor. So it is here in this case, the voltage gain becomes minus Gm into RL upon 1 plus Gm into Re. And moreover, they are directly coupled. Collector of one is connected with the base of the second. This is the first stage. Here, collector is connected to the base directly. The direct coupling. Now we have to discuss now the high frequency response. So for that we draw the equivalent diagram of the first stage of directly coupled amplifiers. The IP is the current, HI is the input impedance, RE the base resistor which is used for the biasing. GM E1 is the current generator, and here this is the load resistance. Now high frequency response means this is the capacitor which we have to consider CD of capacitance CD. Because at the mid frequency we thought that the capacitor behaves as an open circuit for mid frequency. But for high frequency the shunt capacitance cannot be ignored, and we have to take into account this shunt capacitance, because the shunt capacitance, the formula is the reactance is the capacitive reactance is 1 upon JC 2 pi F. Like if the F is high, XC will be less. That means we cannot, at high frequency, we cannot assume that it is like an open circuit, like it is this capacitor behaves as an open. So let we call J omega equals to S. Let J omega equals to S. So J CD omega becomes 1 upon S CD. Now RL and the capacitor CD, they are in parallel. So parallel combination becomes, now simplifying, so this is ZS, mean the parallel combination of resistor and capacitor. Now we know the voltage gain is what? Current gain into the resistance gain. Minus sign mean there is a phase reversal in common emitter. Current gain is HFE. Resistance gain means output resistance, which is ZS. Input resistance is ZI1. RI1 is already calculated. Just you watch my previous video. There the explanation is given. What is RI1? RI1 is HIE bracket 1 plus GM into RE. Now ZS already we calculated here above. Now substituting the two values here, and the gain at the high frequency becomes now you know the HFE upon HIE. This is GM. So let we define F2 as 1 upon 2 pi RLCD. It is let that we are defining it, and already we set S equals to J omega, mean J into 2 pi F, and already in a previous video I calculated AVM, mean voltage gain at the mid frequency. It is minus GM upon 1 plus GM, minus GM into RL upon 1 plus GM into RE. Okay, all that, just this all is incorporating in the above expression. Then that ratio becomes voltage gain of the high frequency upon voltage gain of the mid frequency in magnitude is equals to 1 upon under root of 1 plus F upon F2 whole square. Now if we consider perpendicular F upon F2 base 1 and angle theta h, then and this is not theta h, minus theta h, and tangent of minus theta h is minus tan theta h. So calculating theta h from here, so this is the phase. This is a phase delay at the high frequency. So these two expressions are very important. Number one, the magnitude of the ratio of high frequency upon the mid frequency. That tells that was equals to 1 upon the root of 1 plus f upon f2 whole square. This is very, very important. It shows that as the frequency is increasing, it is on increasing side, the magnitude of AVH mean voltage gain at the high frequency, it gone decreasing with the increasing value of frequency. Now if we set f equals to f2, now what happened? What becomes? The voltage gain becomes 1 over root 2 of the voltage gain of the mid frequency. That is the definition of f2. Upper frequency is that frequency where the voltage gain becomes 1 over root 2 or 0.707 times the gain at the mid frequency. So this is upper bound, or we can say upper cutoff frequency of pass band. You know the bandwidth f1 and f2. So f2 is that frequency which decides the bandwidth, and it is equals to 1 over 2 pi RL into CD. So this frequency depends upon the load resistance. So remember this definition, this f2 value and that value where we say 0.707 times. The two are very, very important. Okay, thank you.